Okay, so we're through 5 generations.
I need one mate. That works, right?
For case 2, we're injecting, we are purposely trying to cause natural selection to happen, right? By selecting against the little a, right? Because it never survives, we're selecting against it. And we record our data for our 5 generations. And again, we want to look at the data at the F5 generation, 5th generation. We want to record our big A, big A, little a, and little a. 3 genotypes at that 5th generation. That's 27. How many of you were homozygous dominant? Raise your hand. Big A, big A. Homozygous. Wait, you did twice. But wait, which were you?
No, I was the first one.
The first one. Alright, so that should be slow.
I just raised my hand.
Okay. Everybody's raised their hands, so I'm on.
Yeah.
Alright, so we have 14 and 12. Okay, so again, our total is 26 here. So for the first one, 14 divided by 26 gives us 54%, so 0.54. And 12 divided by 26, this one will give us 46%, right? And this is just 0. So just like before, we should be able to calculate our P and our Q based on our results, right? So we had 14 individuals that were big A, big A. That means they contributed a total of 28 dominant alleles to the gene pool, right? 28 capital A's. We had 12 individuals that were big A, little a. So they contributed 12 dominants, and they contributed 12 recessives. And we had 0 little a, so obviously they contributed 0 recessives. Right, so based on this, we should be able to calculate our total here would have been 52 alleles total, right? Double our 26. So if we had 28 plus 12 divided by 52, so that's 77% dominant. And then we had 12 out of 52 is recessive, so that's 23%. Okay, so based on these numbers, here's our initial, here's our final. Did we have evolution happening in case 2? Was there evolution here?
Yes.
Yes. Okay, there was evolution. Who can explain to us why we had evolution here? Why was there evolution in case 2? But why did we have evolution? We can see the numbers are different, so that's evidence that evolution has taken place. But why did that evolution take place?
There was discussed.
Well, hopefully, but that's not what caused the evolution. Why did we have the evolution yet?
Well, all the recessives died out, so all species, it went from some dominant, some heterozygous, and some recessive to all either homozygous dominant or heterozygous.
Right, because we had a strong selection against, like Lindsay was saying, homozygous recessives, right? Because they were dying out. And so we saw a shift toward more dominant becoming more dominant.
You might have messed up on the question because I would have said that.
I'll do that next. Alright, that was case 2. Questions on case 2? Alright, let's look at case 3 now, up here. Same thing with case 3. We're going to start off, everybody is big A, little a. And case 3 now, case 3 is what we call the heterozygote advantage. Okay, look up here, folks. For case 3, the same thing. Homozygous recessive, we assume those individuals had sickle cell anemia and they're not surviving and reproducing. So if you get little a, these individuals you just pick again. Okay? Big A, they're going to survive about 50% of the time. And the way we're going to determine this is by the flip of a coin. Right? So I'm going to put some coins back there, and all you got to do is just, everybody should have a coin. If you choose big A, homozygous dominant, you flip the coin. If you get a heads is dead. Right? So head dead. Just remember that. We didn't survive. If you get tails, it does survive. And remember, this is simulating the idea of malaria, right? We said that, especially in certain African countries where sickle cell anemia is common, people who are homozygous dominant are more prone to getting malaria, and it will kill a certain percentage of people. Versus if you are heterozygous, you do not get sickle cell anemia, and it also gives you protection from malaria. So these people always will survive, yeah.
So if you're homozygous recessive, you always die?
Yeah, in actuality, that's not true. It's not that many. But to simplify the simulation, we're assuming that everybody who's homozygous